Good afternoon, ladies and gentlemen. I lead the GSMA project called Future IoT Networks. Thank you. That is much more suitable for my height. What I would like to talk to you today is what is happening in the mobile industry in addressing the opportunity emerging in the smart cities. What are the requirements we can see emerging in the IoT as related to smart cities and actually much wider beyond. The Connected Living program itself was established 6 years ago, and I have been working on the machine-to-machine, bona fide machine-to-machine for the last 6 years. And it's really only in the last year and a half that the IoT as the big term, as a completely new reality, started emerging. And the Connected Living program is focusing on addressing all of the issues around mobilizing and using the cellular capabilities for the world of the Internet of Things to basically enable all of the transformation that might be required. It's one of the 4 programs at the GSMA. We look at a variety of requirements around personal data and authentication. We work with the financial industry on digital commerce. We look at the future requirements of the IP networks and the whole transformation of mobile networks to fit with the requirements of the emerging kind of world around us. This is the digital futurescape, as we call it, and it is part of the big vision that the GSMA has for the overall world requiring the mobility. Now, I work on the assumption that all of you know who the GSMA are. In case you don't, we are a trade association with 800 mobile operator members and over 200 associate members who are tier 1 equipment manufacturers, module manufacturers, device manufacturers, as well as application providers. So all of these companies who are members, and a lot of you in the room, your companies are members of the GSMA as well, are working on a variety of these issues. IoT and the Connected Living is a very big portion of that work. So how did we get to this world of the connected devices, connected everything? Well, the first big factor is the costs, and it doesn't only apply to the cost of connectivity and also the cost of mobile internet, which has come down quite considerably. It applies to the cost of sensors, it applies to the cost of processing, which Samsung described very well this morning. It also is the rise of the smartphones. In many cases, these are used already for a variety of IoT applications, for remote management of different devices, for accessing information. It's the proliferation and pervasive connectivity. So Wi-Fi has been a very big driver of connecting everything, and sort of similar cellular networks as well, but as was mentioned, kind of coverage is complementary, and in many cases it's the combination of technologies that really makes a difference for the Internet of Things. It's the emergence of big data. I think everybody agrees. This is the main value add, and now a lot of companies start understanding and seeing it. And finally, previously, it was unimaginable with the world of IPv4 to connect billions of devices. Simply, there weren't enough addresses, and in some markets, already the service providers are starting to run out of addresses to connect the devices. IPv6 solves that problem, and it allows us to go on and connect pretty much everything that you can think about. So what's different from the traditional mobile services in this world of IoT? Well, first of all, it's the whole variety of verticals that are now coming online. It's a change in the business models. A lot of this has already been mentioned. Now we are looking at the global distribution and managed services that are going to be applying to the world of machine-to-machine and IoT. It's also very clear that connectivity is no longer the main driver of the revenue for the connected machines. In many cases, we are looking at very low average revenue per connection, and it's primarily the value-added services that are driving kind of the revenue and the generation of value in the IoT space. And last but not least, for the mobile operators, there is a very big change in the requirement, which involves the SIM, which is the heart and the core of every mobile GSM phone today. The world of machine is different, and I will talk a little bit about the industry initiative that addresses this difference. We are looking at machines where the SIM is going to be inserted for many years, and there are situations when the devices are manufactured outside of the countries. I mean, in fact, in most cases, devices are manufactured outside of the countries in which they will be used. There is a very big need to then provision the credentials of mobile operators and service providers onto those SIMs on location. And there is a need to potentially re-provision without actually changing the SIM or a module. And this is one of the things that the GSMA has been focusing on. So it was mentioned, I think, yesterday. If we look at kind of the share of cellular, it's pretty significant. 2020, 1 billion was previously forecast by the analyst houses, and it's a portion of other connectivity options, which involves fixed networks, short-range networks. There are a lot of scenarios where cellular is used for connecting a gateway with a variety of short-range technologies for other devices. There is power line in the utilities, there is satellite. This is the reality of the Internet of Things. It's a multiplicity of technologies that are used as needed and where needed. Each of them has a place, and each of them is going to contribute to enabling the Internet of Things come to be. One thing that became clear to us is that already a lot of our operator members are participating in delivering this connectivity. In fact, the latest survey showed that 40% of the world's mobile operators already offer machine-to-machine services, and a lot of them are now starting to switch and understand that IoT is different and the requirements are very different. At the end of the last year, we were looking at overall kind of 800 million of non-handset connections, and of these, about 250 million were proper machine-to-machine, and the rest were tablets and other types of consumer devices that were not handsets, but potentially will be used in the world of the IoT. There are some very clear big markets. Asia, for example, with over 40% of global machine-to-machine connections, and Europe, where nearly, well, 27%, not quite a third, but close to contributing to the global M2M connections. So what became also clear to us is that there is a need for a different type of technologies. And in fact, the forecasts from some of the analyst houses is that as many as 2.7 billion are going to be in place for 2022. This is a new breed of technologies. They will support new IoT applications. They will improve generally the coverage. They will lower the costs. We are looking at under $5 modules. They will extend the battery lives. In many cases, we are looking up to 10, 15 years of battery in place. And they generally are the technologies that will be provided also by the mobile operators. And so they can benefit also from the existing mobile assets, such as security, such as device management, such as authentication, and a variety of other assets. And I'll talk a little bit about what we are doing in this space and what we expect happening in this space. So a lot of the use cases for the IoT have been considered by the GSMA Connected Living program. Some of them are very directly translatable into the smart city. In fact, if you look at the analyst forecasts, they tend to focus on smart city as this very small segment, which includes waste, parking, lighting. But in fact, if you think about the smart city a little bit bigger, there's a lot of need for environmental sensors out there. There's a lot of smart building connectivity. The consumers and medical devices, a lot of them are densely concentrated in the rural, not in the rural, but in the urban areas. Certainly logistics, industrial, in some cases straight in the city, the energy infrastructure, the vending machines. So if we think about the smart city requirements, they're much broader than a very narrow view of what the smart city sometimes is defined as. So what is interesting about all these applications is that the requirements for all of them are extremely different as well. And it led us to believe that, as stated before, not a single technology is in fact capable of addressing of all of these diverse requirements. And once you start connecting all of those devices, there is also a host of other issues that come up. First of all, obviously, devices are now deployed in remote and physically inaccessible locations. They are deployed for very long periods of time. In many cases, they're all battery operated. Some of them, parking is one case in question. Smart metering are all located very deep indoors, very remotely. They need to be very, very cheap. That connected dust that was mentioned earlier, that dust needs to be really very dirt cheap. And new IoT infrastructure for low-cost devices needs to be really very low-cost as well to be able to match the business case, to be able to be profitable and sustainable. Lastly, we need to start looking at the security. It came up time and again during the discussions. The overhead generated from some of the security functionality is quite high, and if we look at the low power wide area technologies, anywhere from 10% overhead, and that's not financial, that's actual traffic, which can make a huge difference in terms of the battery lifetime. What can be done to address this? How to make sure these devices are secured appropriately? Some of the commonly used security protocols may not necessarily be possible to implement for some of these devices. And lastly, we talk a lot to the service providers who mention that they leave a lot of the security to their customers to implement. And that's grand if that's what customers do, and large companies tend to. But when we go into the world of SMEs or even the world of consumers further on into B2B to C scenario, then it very often simply isn't. And so within the GSMA, kind of the mobile industry undertook several projects that are looking at all of these big issues. And the three that I wanted to mention today are the low power wide area networks area, the IoT M2M security, and also the remote M2M provisioning. So very quickly, a look at what is happening and what you will expect to see coming out of the mobile industry over the next 6 to 12 months. First of all, low power wide area, which I referenced previously. We're looking at a completely new set of technologies, a family of technologies in licensed spectrum, which is currently being standardized in 3GPP. So we expect a big release 13 to have a host of standardized technologies from early next year, and they will become commercially available starting from next year and through 2017. A lot of these technologies have a support battery lifetime of 10 years with extended coverage, going deep indoor. The module costs are lower than 2G. The 2G and GPRS are taken as a reference points, and a lot of them are going deeper and cheaper in terms of the cost savings. They do support nomadicity. They do support location-based services to a different degree, but that enables us to kind of cover a lot of new use cases in the city that involves moving objects. And kind of a lot of this, again, are going to be provided by MNOs that I think would do very well to use their existing assets, and security is one of them. Device management is another one that I already mentioned. We want to be able to kind of use the brand and the assets from the MNOs to provide adequate services for the smart cities. So that's the first area. The second one, security. Well, I think it's pretty clear to everyone why we need security. We obviously need to protect personal data that's involved in many of these use cases. We need to guard against fraud. There are many accounts of kind of attempts to take the connected devices and use them for a different purpose, not what the customer has intended. We need to protect the vulnerable. In many cases, these devices are now going to be used by children, by people for assisted living purposes. So there's a huge question of who is responsible and who is liable for protecting this data. And I think that's not necessarily been addressed yet and requires a lot of discussion. we don't necessarily like security. I know we were talking about investing and so on. The reality is that many customers see it as a burden and not an advantage to having it in place. It obviously restricts what they can do. Once they understand the liability questions, then they, in many cases, reconsider even adding the connectivity, and that's something that, as the big industry, we need to solve. It is complex. A lot more companies are more comfortable now dealing with it. Talking to some of the utilities partners, we know that 5 years ago, they may have had one security person covering these areas in the IT team. Now we're looking at 4 or 5, so the understanding of this area is growing. Obviously, it's expensive, and I think we need to do a very good job understanding the balance. Well, if you invest X amount into security, how much further down the line it's going to save you in terms of, addressing risks, for example, or some potential fraud losses. I think there's a huge amount of work explaining to the customers what the value of security protection is. Within the GSMA, we have several groups that work on this area. We look at the requirements in regards to the software remote updates. We come to the conclusion that even tiny sensors that are deployed somewhere in the field, and if security risks are discovered, need to be able to be updated. So there is a very big need to provide some sort of security patch for pretty much all of those devices, even if it is just an image, even if it's not a full update. So there's a lot of work that is going into kind of understanding the requirements, the security requirements within the GSMA. And some of the companies in this room are already working with us. And the main purpose of this work is, in fact, kind of aiming at the enterprise and the customers. Those are the people who make decisions. They are the people who write RFPs, and they put security requirements. In some cases, those are the requirements that they know very well. They're driven by their IT kind of systems and some of the ISO standards. But we need to start explaining to them all those things about cost-benefit, all those things that explain the liability issues and explaining how to deal with it generally. So we are currently working on creating a set of guidelines, which would be kind of using the best practices that already exist in the world of machine-to-machine, in the world of securing the existing mobile networks. And we are looking at creating this document, which we will be sharing with the industry. And I wanted to give you a heads up that in October, we will be sharing this document for industry feedback. So we will be looking at a variety of areas, starting from network security, which is very familiar to mobile operators, to some of the application-related security, endpoint-related security, and also some end-user guidelines. Again, operators currently have quite a lot of experience sort of securing the smartphones and the data on the smartphones. We want to understand how that can transfer to securing the devices that would then potentially sit in the customers' homes or be worn and at all times available and to the end users. And I think we start to understand that there's a lot more that the industry can do to secure those devices, starting from a very simple thing, such as not setting 0000 as the password, but forcing people to perhaps consider changing passwords. It's really small things that can be very strong best practices that we think need to be communicated to some of the service providers and to some MNOs as well. And this is what we aim to do with this document. And the last element is the remote SIM provisioning, which I mentioned as the reprovisionable embedded SIM. The set of technical specifications for embedded SIM were published by the GSMA last year, and similar to kind of SIMs you have in the phones today, you would expect that any SIM from any manufacturer would basically work as soon as you insert it into a handset. A similar thing is now being done with the embedded SIM. So we've got basically the operators who are supporting it currently already provide 65% of global machine-to-machine connections. So now our role is to make sure that the embedded SIMs that are going to be increasingly available in the market are going to be all interoperable and also comply with the required interoperability sets. So the set of interoperability requirements was published in May 2015, and well, from the machine-to-machine, pure machine-to-machine, to actual consumer devices. There's a lot of work defining the architecture and now starting to work on the specifications for consumer devices. So watch this space. I think this will make a huge difference when you can remotely reprovision the SIM for business cases in the IoT space. Is going to be a very big factor. And the last thing I wanted to mention is that I think we need to do a much better job educating that 70% of companies that were quoted who don't understand what exactly IoT would do for them. Now, these are all big numbers. They're kind of the numbers we crunched on the global basis. You know, all the savings for the healthcare, all the the preventing the food wastages, the the opportunity for kids to use the connected devices for education. I mean, those are all the big things, but I'm sure they translate into some pretty significant business cases for a lot of businesses that are small and medium-sized. Just we as an industry need to do a much better job kind of working together and understanding what those business cases are and how we can jointly do the difference. So that's what I wanted to talk to you today. I welcome any questions. Again, I am here through the end of today and happy to discuss any initiatives that the mobile industry have in this space. Thank you very much.